Hello everyone, welcome back to my channel, and in this video we're going to be learning about highest common factor and lowest common multiple. To find the highest common factor between two numbers, we use prime factor decomposition or prime factorization. Prime factor decomposition, I'm just going to call it prime factorization. So here we have a number 16. So when we factorize it, we get 2 into 8, which are the two factors of 16. Now 2 is a prime factor, so we're just going to keep it as it is and move on with 8, which is a composite, so that can be further factorized, which will give us 2 into 4. And again 2 gets circled since it's prime, and 4 continues to get decomposed or factorized as 2 into 2. And so we end the process over here with 4 2's, so that will give us the factorization of 16, which is 16 is equal to 2 into 2 into 2 into 2. Now we have the number 40. 40, which can be considered like this, 4 into 10. Well, it doesn't have to be necessarily 4 into 10, it could be 2 into 20 or any other factor which equals to 40. Here we have 2 into 2, which are both prime numbers, so for 4 the process ends there. For number 10, we have 2 into 5, and 5 is also a prime number along with 2, and therefore we get the prime factorization of 40 as 2 into 2 into 2 into 5. And moving on to the highest common factor which we were discussing, we need to break down our values and find the primes that they share. So an example over here, 36, 2 into 18, where 2 is the prime, and 18 gets further factorized as 2 into 9, where 2 again is the prime, 9 is a composite, and here we have 3 into 3, which are both prime, and the process ends there. So the factorization, the prime factorization of 36 is 2 into 2 into 3 into 3. Yes, or you could say 2 square into 3 square. For 48, same way, 2 is the prime, 24 gets further factorized, 2 again, and 12 here, 6 into 2, 2 again, and 6 gets further simplified, 3 into 2, and that will be the factorization, taking all the factors, so 2 to the power of 4 into 3. Now to find the highest common factor between these two numbers, 36 and 48, we need to find the common prime numbers which they share. Like as you can see, 2 has been crossed out because they're common, another 2 has been crossed out because again they're common, and 3 has been crossed out because it's common. Now the thing is, we have to find the pairs. So for 3 we have 1 pair, for 2 we have 2 pairs, so that means we'll add 2 2's and 1 3. The remaining numbers will not be considered because there is no pair or match for them. So they both share 2 2 3. That means the highest common factor, we have to just multiply the primes that are shared between them, and we'll get our answer as 12. Let's move on to LCM or lowest common multiple. To find the lowest common multiple between two numbers, we still use prime factor decomposition, which is the prime factorization which was discussed in the previous slides. Similarly, we have to break down our values, but this time it's a little bit more complex. Now, same way how we crossed it out, they both share 2 2 3. Now until here the step of finding LCM is similar to finding HCF, but now here we can see that we have to focus on what is left. Now 36 has 3 left, which you can see over here, and here 48 has 2 and another 2 left, which has not been crossed out since the pair is not made. There is no match for it. So this is how it is done. The first 3 multiples, 2 into 2 into 3, is the ones they both share, and then the green circle is the one which is left for 36, and 2 into 2 is the one which is left for 48. Multiplying all of them will give the LCM of 144 for both numbers. Here we have some word problem examples related to highest common factor and lowest common multiple. The first question is, Lisa wants to display some new jewelry in her shop. She has 18 necklaces and 9 sets of earrings. She wants them in groups, with each group having the same combination of necklaces and earrings and none left over. What is the greatest number of groups Lisa can display? Now here the word greatest shows us that we have to use highest common factor in this question. So here we first find the prime decomposition for each number. 18 is equal to 2 into 3 into 3. 9 is equal to 3 into 3. Find the highest common factor. 3 into 3 is equal to 9. And the highest common factor of 18 and 9 is 9. So the greatest possible number of groups is 9, because 18 necklaces could be split into 9 groups of 2 necklaces, and 9 sets of earrings could be split into 9 groups of 1 set of earrings. The greatest number of groups Lisa can display is 9. Here we have another question. Ian is packing equal quantities of grapes and apples for lunch bags. Ian bags the grapes in groups of 10 and the apples in groups of 4. What is the smallest number of apples that he can pack? Now notice the word smallest, which shows that we have to use lowest common multiple over here. So first, find the prime factorization, which is the same step for HCF as well. So 10 is equal to 2 into 5, 4 is equal to 2 into 2. Then calculate the LCM, we get 2 into 2 into 5 is equal to 20. So the lowest common multiple of 10 and 4 is 20. And the smallest number of apples that Ian can pack is 20. That shows that 2 groups of 10 grapes is 20 grapes in total, and 5 groups of 4 apples is 20 apples in total. Therefore, the smallest number of each that Ian can pack is 20. And now here we have questions related to the topic we have learned today. If you want, you can pause the video and have a go and write your answer in the comment section below. And I will be answering them along with you guys as well. So let's look at the first one. Adam and Oliver went to Cade. They bought the same number of tickets, but Adam bought them in packs of 6 and Oliver bought them in packs of 11. What is the smallest possible number of tickets they each bought? So we have to find the LCM of 6 and 11. Using the prime factorization, I'm just going to write it over here for the first question, 6, and then if I further factorize it, I get 2 and 3, and yep, that is the prime factorization is 2 into 3. For 11, there is no prime factorization except one, because 11 itself is a prime number, so it only has 2 factors, 1 and 11. So what is the common which they share? Well, there is nothing there to share, so therefore we just have to multiply everything we have over here to get the LCM. So that means 2 into 3 into 11. I'm not going to include 1 because it's going to be the same thing. 2 into 3 is 6 and 6 into 11 is 66. Therefore, the smallest possible number of tickets they each bought is 66. And yes, the first answer is 66, just like how we did the working. Here we have a bigger question over here. Michael is putting together bags of food to donate to charity. He has 10 boxes of tomato soup and 15 cans of beans. Michael wants to divide them up evenly so that each bag has the same contents and no items are left over. What is the greatest number of bags of food Michael can put together? So this time we have to find the highest common factor of 10 and 15. So let's move on to finding the highest common factor. So 10, I'm just gonna do the prime factorization, 2 and 5, which is done, and 15 we have 3 and 5. Now if you see closely, they share one prime number, which is 5. So 5 and 5, these are the common pair. That means 5 is the only common pair which was found between 10 and 15 when we have done the prime factorization. Now since there is no other number which is shared between these two numbers, it is safe to say that 5 is the highest common factor of 10 and 15. Therefore, the greatest number of bags of food Michael can put together is 5. So we check the answer and it is correct again. 5 is the answer for the third question. Have you got all of them right? Let me know in the comment section below. And yes, that is it for today's video. Thank you for watching, and I hope you enjoyed this video and learned something new. If you did, do consider leaving a like. Do subscribe to my channel if you haven't yet subscribed, and until then I will see you in another video.